better way to start off this video than refreshing our brains with the different laws of exponents? Note that we included this in our tutorial video because we all need to know these laws by heart if we want to know how to efficiently solve problems involving exponential inequalities. An exponential inequality is an inequality in which a variable occurs in an exponent. So, shown in the table in front of you are the different laws of exponents, so let's briefly discuss each. First off, we have the multiplication rule or product rule. It states that when multiplying two powers that have the same base, you can add the exponents and keep the base. Next, we have the division rule or quotient rule. It states that we can divide two powers with the same base by subtracting the exponents while keeping the base. The power of a power rule states that to raise a power to a power, you need to multiply the exponents. In addition, the power of a product rule tells us that we can simplify a power of a product by distributing the exponent to each term inside the parentheses. For the power of a fraction rule, it is used when we want to simplify a fraction that is raised to a power, wherein the exponent gets distributed to both the numerator and the denominator. The zero rule states that any non-zero number raised to the power of 0 equals 1. On the other hand, the negative exponent states that any non-zero number raised to a negative power equals its reciprocal raised to the opposite positive power. The fractional exponent states that when you have a fractional exponent, the numerator is the power and the denominator is the root. And lastly, the one-to-one property states that if x and y are real numbers and if b sub x equals to b sub y, then x equals y.
After recalling the laws of exponents and learning the definition of exponential inequalities, we will then learn the properties of exponential inequalities. Learning these properties would be of great help in arriving at the correct answer when we will solve problems involving exponential inequalities. So now, let us learn the four properties of exponential inequalities. First, if a is greater than 1 and a raised to the power of x is less than a raised to the power of y, then x is less than y. Second, if a is greater than 1 and a raised to the power of x is greater than a raised to the power of y, then x is greater than y. Third, if a is less than 1 but greater than 0 and a raised to the power of x is greater than a raised to the power of y, then x is less than y. Last but not least, if a is less than 1 but greater than 0 and a raised to the power of x is less than a raised to the power of y, then x is greater than y. For a short note, the properties stated above maintain when the less than symbol is replaced by a less than or equal to symbol, and the greater than symbol is replaced by a greater than or equal to symbol. By knowing the properties of exponential inequalities, we will now move on to the steps in solving exponential inequalities. So in solving exponential inequalities, we need to rewrite both sides of the exponential equation as powers of the base. In this, the base must be the same on both sides of the inequality for us to proceed to the next step in solving the equation. Next, we'll bring down the exponents, considering that the two bases are of the same value, since the exponents will be used in solving the variable. Regarding the inequality symbol, we will just skip the direction of it if a is greater than 1, and reverse if a is less than 1 but greater than 0. After doing everything, we will then start solving for the variable. Note, when dividing by a negative value, the inequality symbol will be reversed.
So, you guys should note that in solving exponential inequalities, it is just the same as solving exponential equations. So let's try some examples. We have number 1. 4 raised to the power of x plus 3 is greater than 256. Number 2. We have 81 is greater than 9 raised to the power of x minus 2. Number 3. We have 1/2 raised to the power of x plus 1 is greater than 1/4 raised to the power of 3x. And lastly, we have 1/3 raised to the power of x plus 3 is greater than or equal to 9 raised to the power of negative 3x. Let us start with the first example. We have 4 raised to the power of x plus 3 is greater than 256. So can you remember what the first step is in solving the exponential inequalities? That is right. We have to make the base the same on both sides. How do we do this? So if you think about it, 256 can be written as 4 raised to the fourth power. So if we replace 256 in the problem with 4 raised to the fourth power, our bases are already the same. We accomplished step 1. Now, since the bases are already the same, using the one-to-one property, we can now bring down the exponents. Since the base 4 is greater than 1, we do not need to reverse the inequality symbol. From here, we can now solve for x, so x plus 3 is greater than 4. Now, we will combine the like terms. We move 3 to the other side of the inequality and change its sign. So now we have x is greater than 4 minus 3, so 4 minus 3 is 1. So now we have the answer, which is x is greater than 1. Let us check for the answer. To do this, we have to choose a number that belongs to the domain. For this, let our x be equals to 2. So, let us replace the x in the problem with 2. So, now we have 4 raised to 2 plus 3 is greater than 256. So 2 plus 3 is equals to 5. So now we have 4 to the fifth power is greater than 256. If we get the value of 4 raised to the fifth power, it becomes 1024. So now we have 1024 is greater than 256, which is a true statement. Therefore, the solution to the inequality 4 raised to the power of x plus 3 is greater than 256 is x is greater than 1. Did everyone manage to follow? Great! Let's practice with another example. We have 81 is greater than 9 raised to x minus 2. First thing we need to do is we need to have the same base. What do you think we should do? Note that you can choose which base you will retain. 81 can become 9 squared, or 9 can be expressed as 81 raised to the 1 half. You may choose which one to use, but we suggest that you use the simpler one. Anyways, you will still arrive at the same answer. So for this problem, let's transform 81 into 9 squared. So now, we have 9 squared is greater than 9 raised to x minus 2. Now that we have the same base, we then proceed to bring down the exponents. Again, we do not need to reverse the inequality symbol since the base 9 is greater than 1. So now, we have the inequality 2 is greater than x minus 2. Now, we need to transpose negative 2 to the other side and do not forget the sign after transposing negative 2. The inequality will become 2 plus 2 is greater than x. Finally, we get 4 greater than x, or x is less than 4. To check our answer, let x be equal to 2. We substitute 2 into the value of x in 9 raised to the power of x minus 2. So we have 81 is greater than 9 raised to the power of 2 minus 2. After we compute it, it should give us 9 raised to 0, and anything raised to 0 is always equal to 1. Thus, we have 81 is greater than 1, which is a true statement. Therefore, the solution to the inequality 81 is greater than 9 raised to x minus 2 is x less than 4.
Here's another example. 1 half raised to the power of x plus 1 is greater than 1/4 raised to the power of 3x. Now the first thing that we're going to do is to write both sides of the equation as powers of the base. In other words, we rewrite the equation so that the bases are the same. Now it is up to you to decide which base you will retain, either 1/2 or 1/4. For this solution, we copy 1/2 as the base and then change 1/4 to 1/2 raised to the power of 2. Now that the bases are equal, we can now proceed to solve using the one-to-one property. We bring down the exponents x plus 1 and 2 times 3x. As for the direction of the inequality symbol, let's have a look again at our bases. Since our base is greater than 0 but less than 1, following the properties of exponential inequalities, we reverse the direction of the inequality symbol. Now that we have our final inequality symbol, we can now proceed to solve for the variable. 2 times 3x is equal to 6x. We then isolate the variable by transposing x to the other side. 6x minus x is equal to 5x. We then divide both sides by 5 to get the value of x, which is greater than 1/5. To check if our answer is true, we can substitute the value of x with 1, which belongs to the domain. When we substitute the values of x with 1, we get 1/2 raised to the power of 2 is greater than 1/4 raised to the power of 3. We bring down the inequality symbol and evaluate the problem. 1/2 raised to the power of 2 is equal to 1/4, whereas 1/4 raised to the power of 3 is equal to 1/12. Seeing as our answer is true, the solution therefore to the inequality 1/2 raised to the power of x plus 1 is greater than 1/4 raised to the power of 3x as x is greater than 1/5. One last example. 1/3 raised to the power of x plus 3 is greater than or equal to 9 raised to the power of negative 3x. Like what we did in the previous example, we first write both sides of the equation as powers of the base. 1/3 can be expressed as 3 raised to the power of negative 1, and 9 can be expressed as 3 raised to the power of 2. Now that our bases are equal, we can now proceed to solve using one-to-one property by bringing down the exponents. Since our bases are greater than 1, following the properties of exponential inequalities, we retain the direction of the inequality symbol. Moving on, we can now proceed to solve for the variable. Negative 1 times the quantity x plus 3 is equal to negative x minus 3, and 2 times negative 3x is equal to negative 6x. Next thing we're going to do is to isolate the variable by transposing the constant 3 to the other side and negative 6x on the other, instead of just transposing negative x. We do this so that our variable will remain positive and to make solving for its value easier. Now that we have isolated our variable, we can now proceed to solving. Negative x plus 6x is equal to 5x. Dividing both sides by 5 to get the value of x, we then get 3/5. So our solution for this equation is x is greater than or equal to 3/5, or 3/5 is less than or equal to x. To check if our solution is true, we can substitute the value of x with 1, which belongs to the domain. If we substitute the values of x with 1, we get 1/3 raised to the power of 4 is greater than or equal to 9 raised to the power of negative 3. We bring down the inequality symbol and evaluate the problem. 1/3 raised to the power of 4 is equal to 1 over 81, whereas 9 raised to the power of negative 3 is equal to 1 over 729. Since 1 over 81 is greater than 1 over 729, then the solution to the inequality 1/3 raised to the power of x plus 3 is greater than 9 raised to the power of negative 3x is x is greater than or equal to 3/5.
Now, it is your time to practice solving exponential inequalities. Get a piece of paper, pause this video, and try to solve the two problems involving exponential inequalities that you see on your screen. Got the answers? Great! Let's see if you got the right ones. So, for the first problem, we have 128 raised to the power of x is greater than 16 raised to the power of 2x minus 2. So, the first thing we should do is to make sure that the bases are the same. Now, both bases 128 and 16 can be turned into a base of 2. So first, what should the exponent of 2 be in order to become 128? That's right, it is 7. Next, what should the exponent of 2 be in order to become 16? It is 4. So now, if we input these values into our inequality, we now have 2 raised to the power of 7 multiplied to x is greater than 2 raised to the power of 4 times the quantity 2x minus 2. Then, we have 2 raised to 7x is greater than 2 raised to 8x minus 8. Since the bases are now the same, we can now use the one-to-one property to bring down the exponents. Since the base 2 is greater than 1, there is no need to change the inequality symbol. So, we have 7x is greater than 8x minus 8.
From here, we should combine like terms. So we transfer 8x to the other side, and so we have 7x minus 8x is greater than negative 8. So 7x minus 8x is negative x. So now we have negative x is greater than negative 8. Now this is not yet the final answer, since x still has a negative sign. So what we do is to divide both sides of the inequality by negative 1. Remember, dividing the inequality by a negative value will reverse the inequality symbol. So the solution we end up with is x is less than 8. Let us check if the solution to the inequality 128 raised to the power of x is greater than 16 raised to the power of 2x minus 2 really is x is less than 8. So we do this by choosing a number that is inside the domain, like 1 for example. So we substitute 1 to the values of x in the inequality. So we have 128 raised to the power of 1 is greater than 16 raised to the power of 2 times 1 minus 2. So 128 raised to 1 remains as 128. 16 raised to the power of 2 times 1 minus 2 becomes 16 raised to 2 minus 2, which becomes 0. We all know that anything raised to the power of 0 becomes 1. So we end up with 128 is greater than 1, which is a true statement. Therefore, the solution to the inequality 128 raised to the power of x is greater than 16 raised to the power of 2x minus 2 is x is less than 8. So for the second problem, we have 4 over 49 raised to the power of 2x minus 5 is less than or equal to 3.5 raised to the power of 4 minus x. So the first thing we do is to make sure that the bases are the same. So how do we change 4 over 49 and 3.5 to have a common base? So 4 over 49 can become 2 over 7 raised to the power of 2. Now how about 3.5? This one is actually a bit tricky. However, if you transform 3.5 into a fraction, it actually becomes 7 over 2, which is the reciprocal of 2 over 7. So going back to the law of exponents, when we want to find the reciprocal of a fraction, we give it a negative exponent. So 3.5 actually becomes 2 over 7 raised to the power of negative 1. Now, if we input these values into our solution, we have 2 over 7 raised to the power of 2 times the quantity 2x minus 5 is less than or equal to 2 over 7 raised to the power of negative 1 times the quantity 4 minus x. From there, we solve for the values of the exponents. So 2 over 7 raised to the power of 2 times the quantity 2x minus 5 becomes 4x minus 10. And negative 1 times the quantity 4 minus x becomes negative 4 plus x. So the inequality becomes 2 over 7 raised to the power of 4x minus 10 is less than or equal to 2 over 7 raised to the power of negative 4 plus x. So now, since we have the same bases, we can proceed to bring down the exponents. However, since 2 over 7 is a value between 0 and 1, we need to flip the inequality signs. So now we have 4x minus 10 is greater than or equal to negative 4 plus x. After this, we combine like terms. So now we have 4x minus x is greater than or equal to negative 4 plus 10. So if we solve for that, it becomes 3x is greater than or equal to 6. Next, we have to make the numerical coefficient of x become 1. So we divide both sides of the inequality by 3. So we arrive with x is greater than or equal to 2. Let us now check if x is greater than or equal to 2 is really the solution to the inequality. So to test this, we shall choose a number that is an element of the domain. So let's choose 3 for the value of x. So we shall substitute 3 to all the values of x in the inequality, and so we have 4 over 49 raised to the power of 2 times 3 minus 5 is less than or equal to 3.5 raised to the power of 4 minus 3. So this then becomes 4 over 49 raised to the power of 6 minus 5 is less than or equal to 3.5 raised to the power of 1. This becomes 4 over 49 raised to the power of 1 is less than or equal to 3.5, or simply 4 over 49 is less than or equal to 3.5. This statement is true. Therefore, the solution to the inequality 4 over 49 raised to the power of 2x minus 5 is less than or equal to 3.5 raised to the power of 4 minus x is greater than or equal to 2.
I got the magic in me. Every time I touch that track, it turns into gold. Everybody knows